In our pressure regulators line, we offer cylinder, line, point-of-use regulators, and changeover systems, manual and half-automatic. Pressure regulator is a mechanical device used to reduce pressure of a gas or liquid. The regulator should keep the outlet pressure as constant as possible, regardless of the changes in inlet pressure or of the flow. There are three main mechanisms. On the top of the regulator, there is a loading mechanism. Spring load mechanism is the most common loading device in regulators. The amount of compression placed on the spring by the operator is accomplished by turning the regulator knob in a clockwise direction. In the middle part, there is a sensing element. The diaphragm is relatively inexpensive and adequate for most applications. It provides sensitivity to pressure changes. On the lower part of the regulator, there is a control element. The unbalanced control element has only one sealing point, which is the cone-shaped area of the valve. The unbalanced control element has a negative effect called the supply pressure effect, decaying inlet characteristic. Let's review the forces. In the middle, there is a diaphragm which balances all forces. On one side, there is a spring force of the loading mechanism, and on the other side, there are internal forces, inlet, outlet pressure, and the poppet spring force. Process location. The cylinder regulator is assembled straight onto the gas cylinder. The line regulator is assembled on line, as close as possible to the pressurized device. The changeover system is usually assembled in the gas storage area. Applications include process gas line, gas cabinet, switchover systems, gas skid, the sample is depressurized before it is fed to the analyzer, purging devices. Let's discuss four phenomenons. Hysteresis is the difference in the regulator performance, while the inlet pressure increases versus decreases. Friction works against the movement of the poppet or diaphragm as it opens and closes. Droop is the decreasing in outlet pressure as the flow increases. Operating in the extreme areas, left and right, will lead to sporadic performance. And creep and SP, which will be elaborated in the following slides. Creep is an increase in the outlet pressure when the poppet is closed, which typically causes seat leakage. The causes of creep are contamination. A particle that enters the small orifice, combined with a high flow, can damage the seat and as a result cause a creep. Using a regulator as a shutoff device. If you do need your regulator to be a shutoff device, install a shutoff valve before the regulator. Damaged seat. Matching the seat type to the application, for example, hard seat for high pressure. Its integral filter, together with the shutoff valve option, makes our regulators able to withstand the creep phenomenon. Supply pressure effect, SPE, is defined as the change in outlet pressure as the inlet pressure changes. This usually happens when gas cylinders are used as the pressure source in the customer's system. While the force of the spring is constant, reducing the inlet pressure will increase the outlet pressure to keep the equation balanced. In our example, the pressure regulator is with 1% SPE. Our source is a full gas cylinder, 200 bar. The regulator is set at 30 bar. The contents of the cylinder drops, and the inlet pressure is now at 50 bar. 1% of 150 is 1.5 bar, so the outlet pressure will be 31.5 bar and not 30 as set. For most applications, this is acceptable. However, for applications that require a stable outlet pressure when the inlet pressure changes, we will use a dual-stage regulator or two regulators in a series. Dual-stage regulators reduce the inlet pressure to a lower outlet pressure in two stages. Dual-stage regulators are simply two regulators in series in a common body. This is recommended in cases where there is a potential for large inlet pressure variations. Let's return to the last example. The first stage is the same, but now in the second stage it is regulated again from 31.5 bar to 30 bar. 1% of 1.5 is 0.015 bar, so the outlet pressure will be 30.015 bar. We offer single and dual stage regulators, 4 or 6 connection ports with inlet and outlet hamlet end connections. a wide range of seal materials. The diaphragm is made from Hastelloy, inlet pressure from 300 bar to 12 bar, outlet pressure from 200 bar to 250 millibar. Various cylinder connections and integrated relief valves are available. Changeover or manifold. The changeover system is used for continuous gas applications via more than one independent gas source. It prevents unnecessary downtime by providing a constant gas flow, making the gas management more cost-effective. How does it work? 2 or more gas cylinders feed one point of entry. One cylinder is used until its pressure drops below a certain point. Then, the other cylinder goes into action. The considerations for choosing a regulator are media, configuration, type of regulator, inlet and outlet pressure, and the required end connections. You can always contact our technical support specialists, and we will match the right regulator according to your system requirements. How to order is very intuitive. Our design: minimize dead space for better purging, has a patented dumping system for better control, compact, Hastelloy diaphragm increased cycle life, high corrosion resistance, and has greater sensitivity. Seat materials, greater selection of materials for compatibility and temperature. Purity and cleanliness. Gas purity of up to 6.0 grade nominal, 6 nines. Wetted parts which undergo electropolishing, and multi-stage cleaning processes. Contamination. The integrated mesh filter prevents particles from causing creep or seat leaks. Testing: 12 hours pressure test at nominal pressure. 100% helium leak test for seat less than 5 × 10-6 millibar liters per second. 100% helium leak test for against atmosphere of less than 1 × 10-9 millibar liters per second. 100% functional tests. It allows us to offer higher reliability, longer service life, and lower total cost of ownership. Thank you.